as well. To do this, we simply copy our code, paste it right beneath. Instead of checking for the D key, we'll check for A. And we still want to add a force on the x-axis, but we want to do so in the opposite direction. So we'll just input a minus here. Again, we can save this. Play the game and see that we can now move in both directions. In fact, why don't we go ahead and make our movement speed adjustable in the inspector the same way we did with forward force. To do that, we just add a new public float up here, and we'll call this something like sideways force. Let's just default that to 500. Just add a new this, play the game, and see that we can now move in both directions. In fact, why don't we go ahead and make our movement speed adjustable in the inspector the same way. We did with forward force. To do that, we just add a new public float up here, and we'll call this something like sideways force. Let's just default that to 500. By the way, when we're dealing with float variables, you will notice me writing an F at the end of the number. This just signifies that we're talking about a float number. In some cases we can leave it out, like here, but other times Unity will complain, so it's a good idea to get in the habit of just doing it every time. Again, this only applies to floats, not integers. So now we can take our sideways force and paste it instead of the 500 here, and instead of the 500 here as well. You'll notice that it's still fine putting a minus here. When we run the game, this is just going to be equal to 500, or what we said in the inspector. So let's save this, go back into Unity, and we can now see that we can adjust the sideways. Force as well. So let's try setting the forward force to something like 1000 and the sideways force to something like 600. and it already starts to feel like a game. If you were able to follow along with this, really good job. Programming the movement of the player is definitely not the easiest thing that you can do in Unity, and so it's always annoying that it's really the first thing that you have to do in most cases. But I hope you learned something, and remember, you don't have to understand and definitely not remember all of this the first time. I will just mention that the way that we're handling player movement here is not the most efficient way, but no one expects you to write perfect code right off the bat. I just want to let you know how this could be improved. There's two main problems here. The first one is how we're getting player input. Now, using input.getKey here is totally fine, and in our case it works perfectly, but as soon as we want to do stuff like smoothing player input, supporting alternative keys, or maybe even a controller, Unity has some much better ways to handle the player input, so you can definitely look into that if you want to improve it. Also, we are currently checking for input inside the fixed update. Well, it's fine in our case because what we're doing is movement, and that's usually a fairly smooth thing. It's definitely not a good idea to do for stuff like jumping or other one-off events. The reason for this is that input is updated in the update method, and if the fixed update runs slower, you might have a situation where you actually miss some player input. First, that would just mean that the input gets slightly delayed, and that's why I think it's fine here. But the recommended thing to do is check for input in the update method, then store that input in some sort of variable up here. In our case, that could just be two booleans called something like move right and move left that you'd set to true if the key is pressed and